So the next step of the mantra is zoom and filter. So let's look at zooming. What does zooming do? Zooming helps us focus on a portion of the plotted data. It removes extraneous data that's outside of our zoomed in area. So here's an example of a plot of data across the United States. And in this case, we've zoomed in on a portion of the west to the Midwest. And then we've zoomed in again on a portion of Northern California. And by zooming in at each of these levels, we're removing a large portion of our data set so we can focus on a smaller portion of our data set. And by expanding that smaller portion of our data set to the entire screen, it allows us to use the resolution of the entire display to display more details. So at the highest level, we're just showing the state boundaries, but as we zoom in, we can start to show county boundaries. And then at the finer level, we have enough room to where we can add the names of counties and other data about each of the counties. And so by focusing on a small portion of our data, we can ignore large amounts of data, and we can add more detail about the data we're specifically looking at. And so there's two ways of zooming. There's this way where we're looking at a portion of our data set, a portion of the displayed coordinates of our data set by, for example, clicking a window. Or we can also expand axis fields. So for example, if you're plotting data over time, you might be looking at it by year. If you want to focus on the year 2014, then you could click on 2014 and expand that into quarters. And we could look at, say, the first 3 quarters of 2014 and ignore 2013 and 2015, so we can use our resolution to more clearly see what's happening at each quarter. And then we may be interested in quarter 2, and you could expand that and look at the individual months, April, May, and June of quarter 2, and ignore, for example, the months in quarter 1 and quarter 3. So in each of these cases, zooming allows us to take the displayed data and to expand it to be able to focus on a portion of the displayed data and ignore the rest of our data set that's not in that subset of our displayed data. So here we've used Tableau to plot our life expectancy data versus population for every country in the world, and some of the data clumps up. We have a big collection here of a bunch of countries that have similar populations and life expectancy, and there's not enough resolution to be able to know which one we're pointing at if we're looking at that. So if I want to find out, in these clumpy areas what's going on, I would zoom. And so I would show these zoom controls, go over here and zoom in on this data. And that will spread things out. And I can see, for example, this clump was Norway, Singapore, and New Zealand that all have similar populations and life expectancies. And some of these other clumps can be differentiated. For example, West Bank and Gaza and Lithuania have similar life expectancy and populations. Or over here we've got Argentina and Poland. And so by zooming in on the data, we can use the resolution available on our display screen to better differentiate similar items. And then we can always zoom back if we want to see where things are in the original context. When we zoom in on a portion of our plotted data, we're completely ignoring the portion of the data that's outside of that zoom window. Often that can cause us to get lost in the data. We're looking at a fine level and we forget where that fine level of data that we're focusing on sits within the larger data set. So there are tools that help us to combine the focus of zooming with the context of the big picture of the entire data set. And these are called lenses. They're interactive lenses that you can drag around. Sometimes they're called magic lenses, depending on what they show. And they allow you to zoom in on details. For example, here's a data set, and we can drag around this zoom lens, and it uniformly magnifies everything underneath it, but you can still see where you are relative to the large data set. But in this case, we have a uniform level of magnification, so the data that's underneath the periphery of this lens is being obscured. We're magnifying this portion of the data, but for example, we've really lost the detail of the region of data out away from that magnified edge because it's being obscured by the magnified data. There are fisheye distortion lenses that help fix that problem. In a fisheye lens, you've got a lot of magnification at the center of the lens, and as you move away from the center, you've got less magnification. And as you get towards the periphery of the lens, you get no magnification. The magnification goes to 1, and so you basically, as you cross the lens, you don't see any change in magnification. That way we can push away some of the details from the center, and we get this seamless transition from the outer context into the zoom details that we're looking at. In this case, these three spheres, these three light green spheres, are the three large spheres that we're basically occluding everything here. And as we push them away, because they're away from the center, we can start to magnify 5 very, very small spheres that were being occluded by these large spheres. And they, and for example, these 3 spheres are basically these 3 spheres. They're uniformly distributed 1, 2, 3 here, and you can see that the first sphere here is farther away than the other 2. That's because the magnification of this sphere is greater than the magnification of these spheres, and so the distance is getting magnified more here than it was here. And so these fisheye distortion lenses give us a nice combination of the ability to zoom in on data, but to see it in a context of the big picture. So the D3 JavaScript library has some good tools for doing a fisheye distortion that nicely demonstrate it. So here, for example, we have a graph, and you can see that the graph contains a lot of clusters of nodes, and it's hard to see what's going on with all the edges inside those clusters. But if I put the mouse near it, then we get a magnification. You can start to see the differences. There's still a lot of lines there, but you can magnify the positions of the nodes, spread the nodes out with this fisheye distortion lens, and see what's going on with the edges while still connecting to the context of the remainder of the graph. So you still get your big picture of the whole graph, but you can zoom in on individual elements. And later on in the page they show an example of how this distortion works. It's basically creating a small vector field that offsets the vertices or pixels, depending on if you're looking at primitive data with vertices or if you're looking at image data with pixels. And then you can do the lensing to the entire screen in a rectilinear way, or you can just do it to a small cylindrical or a small disc-shaped portion. And here's some other data. In this case, you've got data that's plotted by area, and there's a lot of overlap and a lot of small details and large details, and as you drag over these regions by distorting the entire field, then you can see the intricate relationship between the data in your focus while still maintaining the context of where that data lies in the rest of the data set, in the context of the rest of the data set. So these fisheye lenses provide a nice compromise of both focus and context.